about on Monday is this, do you think? Well, no thoughts? Any guesses? What do you think, Emily? Unordered arrangements, yeah. So this is a combination then that tells us. Because the jobs are identical, it's just I'm hiring these 3 people in for identical jobs, then I am going to take the 10 and choose 3 unordered arrangements. So what do we get from that? So just to show setup for a combination, what your calculator is doing with the NCR is it's doing 10 factorial, and then 10 minus 3 factorial, and then 3 factorial. And you get 120 groups. Okay. Ms. Comrie gives her algebra class 15 study questions from which she will select 10 to be answered on the final exam. How many ways can she select questions? And I guess what I'm thinking is how many ways is it going to matter? Like, for instance, if you've studied the 15 questions and I pick 10, those 10 could be in any order. It wouldn't matter, right? They would just be on the exam. So in this case, order does not matter. So how would I set up this one then? This is also a combination. So 15C10. I'm going to write here, order wouldn't matter. Order wouldn't matter. Okay, so 15C10 is 3,003 different ways. Or I should say different tests, that would be. Okay, so then let's take a look at number 3. A restaurant is offering a deal where you can choose, and that should be not and, an appetizer, entree, and dessert for $9.99. If you can choose from 8 appetizers, 5 entrees, and 4 desserts, how many meals can you make? What's this one? Okay, so if you would do a permutation, explain to me then. How many things are you going to get when your meal comes, or the entire deal? 3. Think of, you have 3 groups of things. We have appetizers, entrees, and desserts. How would I figure that out? So if these are my 3 things, how many different appetizers can I choose? How many entrees can I choose? How many desserts can I choose? What do we call this? Multiplication counting principle. Okay, when I have different ways of doing, I guess, different tasks, or in this case, ordering different types of parts of the meal, then I multiply the choices together. So what is 8 times 5 times 4? 116. Okay, so number 4, Mr. Burger offers a hamburger with up to 10 toppings. How many burgers can you order? Okay, so the reason why this is different than the ones I've been doing before is, like, in number 1, they have to select 3 jobs. In number 2, I am going to select 10 questions. In number 3, I have an appetizer, an entree, and a dessert. So, and you said subsets, right? Because you could order a burger with no topping. You could order a burger with 1 topping, and so on, all the way up to 10 toppings. So we have to find all the different ways of each of those cases and add them together. But in class I said if you are adding up an entire subset, what could you do instead of taking the time to do that? Do you remember? Good, Carmen. So, because there's 10 choices, it's 2 to the 10th. You can do that all out, but you should get the same thing. And that would mean there's 1,024 different burgers you could order. Okay. So number 5. You are buying a new car. You have 4 colors to choose from. You have 3 models to choose from, and up to 8 additional options. So we have the model, we have the color, and then we have the options. Those are my 3 categories. So kind of on the outside looking, it looks like it's a multiplication counting principle, and it is. But the last part has a little bit of a twist to it because it says up to 8 options. So how many choices do we have for color? 4. And then how many choices do we have for model? 3. If I said up to additional options, in this blank here, I would have to do, let's say they got no additional options, 1, 2, that part is a subset, so it's going to be 2 to the 8th to figure out the additional options. So we do that. And that gives us 3,072 cars to choose from.